Okay, apologies for needing to pause. But this is going to be, I suppose, part 3. Um, yeah. Okay, so upsetting the balance, natural balance, ozone destruction. So, as ozone depletes, as mentioned in the previous video, UVC is the type of radiation that we don't have to worry about unless we make it a problem. That's because naturally, the ozone and oxygen, um, they work together to completely absorb UVC, so it doesn't reach Earth's surface. So as we damage the ozone by depleting its concentration in the stratosphere, we are allowing UVC to enter the Earth's surface, and this is considered the most dangerous radiation, UV radiation. So whether you believe it or not, evaporated water, or basically water vapor, when it reaches the stratosphere, it's considered a greenhouse gas because it's broken down by UV photons. So, yeah, water with exposure to UV photons, it produces free radicals. So, also in the previous video, I showed you this. The dot means, well, it's supposed to mean that something is a free radical. So, free radicals are dangerous for the ozone. For one, atomic chlorine is a free radical, and it essentially acts as a catalyst, which a chemical substance that participates in a chemical reaction, and basically without it speeds up the process without undergoing permanent change. So in perspective, just one atomic chlorine can catalyze the destruction of up to 1 times 10 raised to 5 ozone molecules. So that's a lot just for one atomic chlorine. I haven't introduced to you yet, but CFCs is an abbreviation for chlorofluorocarbons. It's non-toxic, non-flammable, cheap, and widely available. In some air conditioning units, this is what's being released. So, in some cases where you turn on the AC in open air, well, that's dangerous because you are releasing CFCs to the atmosphere, and that contributes to the destruction of ozone. So, what is the structure of CFC? So, we have carbon in the middle, we have chlorine, chlorine, fluorine, fluorine. So, once we expose it to UV photon, more specifically the one that's less than 220 nanometers, I believe this is UVC. So, it becomes, well, what's produced is a chlorine, an atomic chlorine. So, this atomic chlorine, together with ozone, produces this radical and oxygen, and that radical combined with an atomic oxygen produces more atomic chlorine. Then basically the cycle just repeats. So it's dangerous essentially. So if CFCs are dangerous, what are the alternatives? We have two, three, well more. I'll be discussing two. So this one, HCFCs, is in other words hydrochlorofluorocarbons. So that's about it. HFCs, hydrofluorocarbons, essentially what's good about this is it replaces the atomic chlorine that's released by chlorofluorocarbons with just H, atomic hydrogen, I believe. So essentially, the prevention of the release of atomic chlorine means that this doesn't have to happen. So the catalyzation of the destruction of ozone molecules will not happen. But essentially, still, the downside for HFCs is that it is still technically considered a greenhouse gas, and it contributes to the warming of the earth. So, yeah. I find it difficult to explain this, but I'll try. Um, this, by the way, is unrelated. This is the science behind sunscreens. So sunscreens contain metal oxides that protect you from UV radiation. So as you gain energy, I think that's the meaning here. Um, Photon absorption, you reach the excited state, but with heat loss, you reach the ground state. What is this? Okay. I believe these are the components of the types that are found in specific kinds of sunscreen. So, as you can see here, a sunscreen that contains these are capable of dealing with UVB radiation. The red ones capable of dealing with UVA, but the green ones are capable of addressing all both UVA and UVB. I think that's what that means. Okay, I think that's it for this video. Um, yeah, thanks for watching.